Hello, everyone. I believe that I made it on. Wonderful. So, welcome to the presentation. I do believe I'm sharing my screen for Computer Science MacGyver Style. Do let me know in the comments if you can't see your screen. Or actually, why don't you just give me some thumbs up or affirmation through the chat. All right, excellent, excellent. Welcome to Computer Science MacGyver Style. My name is Claire Bakta, and many of you in the comments as we started were telling me that I see some teachers in here. I see an RSP teacher for 4th through 6th grade. What else do you guys teach, or what else do you do? Go ahead and write that in the comments as we get started. Now, on your screens, you should also see my screen share that says Computer Science MacGyver Style, and you have an image of MacGyver climbing up the screen. IT, very nice. Data analyst, nice. Excellent. Special education in a virtual high school. Nice. Excellent. Well, we have an amazing, I encourage you guys to look at the comments because you are an amazing group of people and you were very brave because you showed up to teach Computer Science MacGyver Style to your students. My name is Claire Bakta and I teach CTE Computer Science, which is definitely more professional based, hands-on. And I did this today because I think about MacGyver a lot these days, ever since we entered the pandemic. Let me get my thing to show. We have, in my memories, MacGyver could do anything. Here's a picture. I haven't watched the new one. I'm a fan of the old. If you gave him a paper clip and a rubber band, he could stave off disaster. He could do it under tight pressure, tight deadlines, and dangerous circumstances. And I feel that is exactly what we do as teachers in a pandemic every day. So I do want to take a second and just congratulate you. You're still in the spirit if you're attending a MacGyver style virtual conference session on how to teach computer science. You are definitely up for the challenge. Now, MacGyver, I realized as I prepared for this session, MacGyver would not tell you how to teach. He would not tell you what to do with your day or how to introduce this into your life, but he might enlist you in a very important mission. And that mission is this: to expose every student to computer and data science. Now, he would probably have you find your own paperclip because this is a remote environment, but he would throw you an emergency subplan. Because as I sat down to do this, we as teachers already have so much on our plate. We're already balancing so many new things with this pandemic. So how could I make this so it actually got into all of your classes? By all means, if you want to teach it in your regular day, yes. But I'm also making this so it could just be a sub-plan so that when you do get a second to get away from your classroom, whether it's an emergency or a day away, whatever that reason is, you could use that as an opportunity to expose students to computer and data science. Okay, now this is the challenge. This is my challenge. This is why I care so passionately about this. As a CTE computer science, I am teaching high school right now. And what I see every day at the start of every class is that students have already decided before they learn a single snippet of code, they have already decided whether code is for them or not. Now, the students who excel in this are not easily identifiable. And sure, there's some students out there that you'd say, hey, I bet they'd be really good at code, or they're very interested in video games. That'll probably work. And they probably will be. But it is the students that you least suspect that will always surprise you. And most of my best students, this is very qualitative, but most of my best students in 10 years of teaching students how to code and how to create have actually been on IEPs. And so I feel like this is a great audience to actually help me in my mission of exposing all students to computer and data science, because that is the exciting world that we're in right now. So this subplan to expose every student. And what we're doing today is a very much like the subplan I would lead you through. We're going to talk about what is an algorithm. We're going to talk about why have I chosen this wacky net logo. We're going to explore some models in our class. We're going to share our models on a class Jamboard since we're remote. And I'm going to show you where these lesson plans and student lesson pages are. Now, you guys have me as a speaker. So you get to hear me. I also have videos. So for each of these things that I'm expressing to you here in person, I also have a video for your students to watch so they can still get all this background information. Now, if you do have questions at any point, by all means, speak up. I have a moderator who's going to help me pay attention to that in case I don't, but I will also have questions at the end. All right, so why? Now, I don't know if I did not learn in science class that there was an algorithm in everyday life. There is a mathematical model to how birds fly in a V, how fish swim in a school, how ants follow in a line, and even how bees create perfect hexagons in their honeycomb patterns. I didn't learn that in science class, and I have to admit, I was more looking towards the arts at that point in my time. But where I learned this, where I learned about these algorithms in everyday life, was actually in an animation class. And that blew my mind. Now, I like NetLogo for very similar reasons, because it allows us to interact with data in a way that students who have already sworn off, maybe they don't like math, maybe they don't like science, they do like playing on computers. And so this is a great way for them to get into that. And an algorithm is simply a specific set of instructions. Now, algorithms are at the core of every model in NetLogo, and algorithms are the basic building blocks that we use in code. So that's how we start out. Now, NetLogo is interesting. NetLogo is not a tool that people usually learn how to code in. NetLogo is actually a real world data modeling open source software. It comes out of Northwestern University, and it is free and open to anyone who wants to use it. And when you go to explore it, you will find hundreds of models about day-to-day things. So for instance, this image on your screen, this is a screenshot from a model showing fish tank, the genetic drift in a fish tank. You will see lightning on the screen. Now, what's interesting about NetLogo is that it lets students not just like see pictures, but it lets them interact with the individual variables, the individual pieces, and lets them play and see the impact on the whole. And that I'm going to show you in a second. But the reason I love NetLogo is this. I think it's a really neat place to explore, to play, and learn. And we get to see and interact with the algorithms that are all around us. And so I think every student benefits from being exposed to this stuff and basically playing around. So I am going to go straight to the Northwestern page, and do tell me if when I switch screens like this, if it has affected our screen sharing. Looks fine so far. And what I'm going to do, this is the NetLogo website. It is important to note that NetLogo is not at netlogo.com. That is some other company. This is out of Northwestern University. And when I come to this page that you should see on my screen, I haven't heard any complaints yet, we are going to go to the NetLogo web. Yes, there is a link for the presentation, and it is, I'm going to show you that. It is all the way at the top of the chat. You will find it. And it's a bit.ly MacGyver Teach. All right, so excellent. Perfect. I like this. All right, so here I showed up on the NetLogo site. Here I am on the NetLogo site, and I'm going to make this bigger. And every time you come to the NetLogo site, it actually automatically loads a different model. So this model that you see here is wolf sheep predation, right? Okay, so this is going to, and I can learn all models have these things in common. This is where you'll actually see things happen. These are the pieces of it. And we don't really really know what the models are like until we go down to the bottom. And you see there are 3 tabs right here. I'm going to look at model info. When model info will always tell you what it's about. So this explores the stability of predator-prey ecosystems. Okay, and so there's 2 variations. This is going to tell me how to use it. And it tells us, usually it's press the setup, press the go, and then play with the variables. But here it'll tell you things to notice, things to try, and how you could extend it. Now, this here, this second tab, is the NetLogo code. And this is actually the code. This is actually the algorithm behind it. And the command center is if that you could actually interact with it by code, but you could interact with it here. So this is what we're going to do. We're going to look here. We're going to hit setup. There we go. And we're going to hit go. All right. So here we see in this graph, we see the population of sheep. It's something's going on. We see that it's changed. I can play with this. I can change the rate at which sheep are reproducing. I could change the rate at which wolves are reproducing. And obviously I can, I'm down to 0 wolves. Once the wolves are extinct, they're gone. If I ever want to stop, I can hit setup again. I can stop with go. So what I want to show you, that's just one. What I can show you is up here at the top. Up here at the top center, you can search the models library. So what I want you to do, and you can do, you can see there's a wide range. There's anything from termites to tumors to how ants travel to social models of rebellion and chaos, even down to artistic models of fireworks and fractals, or even just good old-fashioned video games. Okay, so literally and I've done this assignment with my students, there's literally something for every student in here. And what I like about it is they get to find something with their interest level and they get to play and interact with it. Okay, so I also like it for this. When you actually get to have all your students, like you're going to do today, you're going to play on here, but you're also going to share with the group what interested you. And I think it's a really fascinating, I've assigned this a couple times to a couple different classes now, and they don't just pull off the top. They all come up with different things that interest them. And it kind of helps you understand how do you tune into your students' interests and like, where is their mind at? So up here, you can search with this drop-down model, or you could, for instance, type something like ants. Now, I love this ant adaptation model. I'm going to show it to you. I'm going to review what we talked about one more time. If I want to learn about the model, it's down here in the model info. And so this is following rules, right? This is what you're looking at is the complexities at play with ants. And so the things that come into this are their size, their aggression, their energy required. And here you actually can add chemicals, vinegar, flowers. And like all models, you can come here, you want to hit play. Okay, so here we have my blue ants. Here we have, and you see there's a number under here. So far my blue ants are storing slightly more food than my red ants. But watch this. If I raise the aggression of my red ants, you begin to see that the red ant food begins to skyrocket. And you begin to see that they start invading everything, their whole ecosystem changed. Now, in code, these are variables. The size of the ant, the aggression of the ant, all these things are variables that they can play with. And so what I want, and here we go, I can also come here and say, okay, I'm going to give the blue ants a lot more food. Okay, and suddenly that just changing the food source, it doesn't matter about the aggression anymore. These guys are actually getting an advantage. But if I come back in and I do anything with a chemical, you begin to see my food source and everything begins to drop. And so that is just how you play. There's no wrong way to play with a model. It always, if you want to stop it, you can stop, play. Usually on models, there's a setup and a go, right? And so what I want us to do, I want you to get onto this site. You can follow the presentation or you could do a web search for Net Logo. And I want you to get on the web version. No need to download anything. That's not what MacGyver's about. And what I want to do is I want to give you 5 minutes. Excellent. 5 minutes for you to explore. And then I'm going to come back to you. I'm going to show you here. I want you to actually come back to our presentation. We have a class Jamboard that I want you to come back and share on. So I don't know if you've used Jamboard before, but if you haven't, super easy. Your controls are all down the left side of the screen. And you can choose a sticky note. You can choose your color of your sticky note. And what I want you to do is I explored ants. If you give them more food, they do great, right? I don't know what your observation is, but I want you to talk about what did you explore? What did you play with? And I want you to save it onto this Jamboard. Do you guys have any questions about that process? All right, so 5 minutes, that means at 10:51 my time, we'll get back online. We'll all be back here together. I am here to answer any questions you have in the meantime through the chat. But I look forward to see what you guys interacted with and what you thought was interesting. All right, I'll see you back at 10:51. Hello, Rudy. and there is no way to do this wrong. I feel like that's the most important part of this assignment. There's no way to do this wrong. So go ahead, tell me what you explored, because this part is really interesting to me. Um, nice. I also, I usually give my students more time. I definitely give them more time than 5 minutes. It's just the abbreviated format here. And I usually ask them to explore at least 3 models, and that way they don't have to decide. Ah. Okay, well, that is a good point. All right, let me just show you because I think I'm still sharing. NetLogo is just a graphical display of mathematical models, and I like it because I feel like any student can come in here and find something they like, even if it is Pac-Man. And some students find. So here we go. You can even play. Oh, maybe Pac-Man's broken. I'm going to try, I know Tetris works because I've played it here. So you can start new and play. What I also like is that even your kids that are only going to like games are definitely going to actually kind of look here and begin to understand what goes into that game. There we go. Yeah, couldn't get Pac-Man to work either. Huh, it's not just me. Good. I feel like, it's presenter's luck. Nice. Good. Wolves and sheep. Nice. All right. Well, I have 29 attendees here. And so what I want to do is I want to break it in more like a class. Let me just make sure my message is here. Hold on. Never used the web version. What does the HTML, one of the questions in the comments, what does the HTML section does? Honestly, if you are on the desktop version of this, you can actually make these models. It's not hard at all. The HTML section of this actually lets you download the model that you've created. But really, what I'm using it as is I'm really sort of using it improperly, right? MacGyver isn't actually clipping papers with his paper clip. I am using it improperly. I am totally using it to just like throw kids in real world environments and let them manipulate and play with data. Okay, now we can also, and this is the other very interesting thing, we can also come in here and it turns out that the NetLogo language is very easy. It's very clear cut, has very clear cut lines of what works and doesn't. And so I feel like if you're going to expose your kids to at least one line of code and get them to succeed, this is a great place to start that. So I'm going to gather us back. I want to take us back to our page. And, and so I'm going to look at this. And by all means, this is what I've learned about remote teaching. One of the things I miss about being in a classroom is noise. So what I want you guys to do, if you're up for it, feel free, unmute yourself, and let's just ask some questions and talk about things. And it's okay. If you are lost, you don't have to know what you're doing. So let's see, because what we're going to do is get a little bit more feedback to help you. And we're going to talk about what we explored. You can't unmute. I wonder if I can unmute you. Oh, that's so funny. Oh, we did not have access to unmute. Huh, only chats. Well, I guess I'm just going to have to keep missing the sound of students because I don't have the ability to unmute you either. My bad. So what questions do you have? So let's look at this. So I'm going to moderate. Now, what I would suggest is in your class, if you bring this there, definitely in the lesson plans I give you, there's videos that tell you how to explore. So things are more repeatable. So what we did here, for those who feel like they were lost, I'm going to come up here. We went to NetLogo Web, which is this, and all we did was we looked for things that interested us. We looked for models that interested us. You can look for the model info down here and kind of see like, this is based on an arcade game, and it'll tell us what the object is. So if I hit setup and go, oh, these are my controls. Ah, nice, we can play. And so all I wanted you to do in this section was to play around, because every student I've worked on with this has found something in this long list of things that is of interest to them. And it may be video games, it may be, let's see, maybe video games. There's some examples of neural networks in here for artificial intelligence. There are some sociological models of war and rebellion. There's scientific models of physics. There's artistic models of, so the sky is the limit. There is something of every part in the world that is here, okay? So, and when you teach this to your students, the important part is to say, you can't do this wrong, right? You can't do this wrong. And I feel like as we interact with data science and computer science with our students, the most important lesson you can teach them is mistakes happen. Mistakes happen. And so, you know, we can fix mistakes. We all get lost and find, but questions are good. There's no doing wrong. So there's a comment in here that says, this is pretty elementary. So are we talking to really young students? Well, you know, this is really interesting because visually, these are not your most like elegant, like visuals going on, right? But actually, NetLogo is a real world tool. Like real academics and scientists and people create these models and share them. So it's interestingly enough, this is actually like a real world tool. You can buy a textbook that is like this big about how to make scientific models and how do you do data modeling, and it's just a different way of playing with really giant sets of data and really complex systems, and allowing us as users to actually just get in there and play with the variables and the elements. And so for me, in the same way that it blew my mind that if I wanted my fish to swim in the ocean like the real world, there was an algorithm that could tell me how to do that. This is a way that kids can actually understand and interact with science and math and data. So it can be, I believe it can be from young kids all the way up, right? Because there's something for everyone. I was doing it with high school students. I was doing it with our San Joaquin County one program students. Now, I didn't get every student to love how to learn how to code in here, but I did get every student to explore. And I thought that was kind of a really neat thing, because I have a 5-year-old daughter. She asks why about everything. By the time we're in high school, we're not asking why as much, right? And this brings us back to that spot where we could actually ask why. So if we look here, this is just our random sampling, right? The things that we got to explore pollution, viral spread in human populations. We all kind of wanted to play with Pac-Man, but also realized that games are important. We played with waterfalls, we played with collisions, we played with ants, sunflowers, and at no point did somebody say, I'm bored. Well, you're adults, you're not going to admit that as much. And there were a few that got lost, and that I do apologize for. That is the downfall of teaching. But it really is just a neat way for us to talk about the world around us. Now, if you introduce this into your classroom and they play here, I'm working on a game about bees. And it was really interesting because I was like, well, actually, I might be able to find some of the algorithms about how bees behave on NetLogo, right? And so it becomes a place that you can reference information like, how do forest fires spread? And there's a mathematical model for that. And so on some level, you want kids to make those connections that they can come back here and attach it to the stuff maybe they're working on in science. Maybe they just want to play a game. Maybe they want to just, just learn. So that is a little bit about that part, right? Now, I believe the emergency MacGyver subplan is totally about this exploration phase, right? This is just getting them exposed to it. I had mixed results. Well, this is getting them exposed to it. So if you're in person, if you're not teaching remotely, what I would do is I would have them make posters. I would let them bring out their art and their interests, and I want you to make a poster about what you explored, and allow them to show you about ants and volcanoes and fireworks, and really kind of show that breadth of information. Because when you do this across a class, I did it with one class that actually, some classes that had 30 people in them, and it was this incredible range of information, right? And if you have 30 students in front of you and you actually get to see what are you interested in, and they can actually go and play with these complicated models and give that information back to you, I think it's a win. Now, I believe that the jobs of our future in technology, there's thousands and thousands of jobs in our future. Being a coder is just one part of what tech is. And it is important that we expose all of our students to it. They may not all want to be the coders, but some of them may be the artists. Some of them may be the creative thinkers and doers that are really needed in our future jobs, because they're the ones that are going to be able to control this technology. Now, in the future, our artificial intelligence is going to be creating our own code, right? Our machines make code for us. But what we need are inquisitive students with creative, out-of-the-box thinking. And that, training them not to be scared of code, training them to not be scared and understand that they can manipulate data, it's pretty breathtaking, right? And so these are advanced mathematical models. These are complex systems, and we can play with them like video games. And that is what our technology can do. Nice, good. All right, so what I want to do now, I'm going to go back to this. It definitely is a whirlwind. I would have a longer conversation with you guys, but I want to do this because I feel like if every student out there at least writes one line of code, then when they come to my class, they're not going to be like, no, I don't do that, right? Like, have you ever done it? You're like, oh yeah, I did that once, right? I feel like if not coding is an identity, we need to put code into their hands and break that. Now, I'm going to say this too. If they hate to code, if your students hate to code in NetLogo, do not force them, right? Make it extra credit. There's many ways you can talk to your computer. Code is simply talking to your computer or your device and getting it to do what you want. And in today's day and age, typing and scripting out lines of code, that's one way. There's all sorts of amazing tools for visual coding, but I like to do this and give them like a range. So, oh, you didn't like this? Well, maybe you'll like Scratch, or maybe you'll like MakeCode, right? So it's just one first step. This is just about exposure. All right, so this is what I want you to do. From this presentation, I'm going to say click here to code one thing, but you can also find this by going to the Ninja Pandas are plural, website, and I have it right here for today's class, NetLogo. And when you come, if you follow NetLogo, you're going to find, if you're an educator, you want those lesson plans, you can follow that path. But I'm going to pretend to be a student because we're students today. Now, that exploring workshop and all that would be off this button, but we want to take it here and create. So these lesson pages have everything built into them, because the one thing I've learned with my students is that they hate to go from place to place. Well, my students get lost going place to place. And so I've embedded where you code right here with all of your resources. Here are some videos to help you. Here are, like, for instance, a color chart. Should you want to know colors? Should you want to know shapes? So here are all your resources that you may need. And today, if you want, here's a code sheet that, for instance, is going to give you some tips on how to do some simple things. So what I want to do is show you where you can code in NetLogo. So if you're a student, there's some videos that are going to teach you this, but this is an empty model. So you see, it actually says empty up here. This is actually exported out of NetLogo just as an empty model. And it allows me to code in it and then execute my code and watch it up here. So for instance, here in the command line center, I can do something like this. Now, NetLogo is a language of patches and turtles. And patches are the ground below them, or the background. And turtles are the objects that crawl across. And so it's a very polite language. So we're going to say ask patches. Now you'll see on your computer that both of those colors, both of those words are a color. If it is black, it means it's a reserved word. And so if you were trying to speak directly to the computer in its language, and what you asked for was in black text, you were doing it wrong. So I'm going to ask patches. Now, all computer languages have syntax is what it's called. So you can ask patches and it's going to listen to whatever is in your brackets. Now in code, if you open a bracket, you have to close a bracket. It's like if you open a door and you don't close the door, all sorts of things you don't want are going to come in. So I'm going to ask the patches. Now, I don't memorize all these things. I look them up, right? And I feel like that's incredibly important for students to see. There's a NetLogo. I have a sheet of code for you, but there's also just like an API that'll break it down. But I'm going to say set p color, and I'm going to say red. Now, I know red is a word that it understands because I found it on my chart. But for instance, look, it doesn't have purple, it calls it violet, right? And so all computer coding is learning how to specifically talk to this particular language and computer. So I'm going to close my bracket, and when I hit enter, there it is. Now I'm going to show you, like, let's say I want to turn it purple, right? And when you show stuff, I want you to make sure that you are not flawless. It is incredibly important that you make mistakes in front of your students because they need to see that you make mistakes and how you fix mistakes. And I intentionally make mistakes even in my videos because they need to understand what happens when something goes wrong and how to make it right. So I'm going to say ask patches, right? And I do square brackets, set p color. I'm going to set it to purple. Now, you'll notice that purple is black, right? So it is a reserved word. Now, that doesn't mean you can't make a variable and that could be it. But because I'm specifically asking it to turn it purple, that black text is a good sense that something may go wrong. I'm going to hit enter. And it's like, hey, I've never heard of purple before. I don't know what you're talking about. So I'm going to try it one more time. I'm going to say, ask patches. I'm going to look up at my color chart. I'm going to realize, you can call it by these just pre-done colors or any number on this gradient, right? I'm going to come back here, ask patches to set p color for violet. Now you notice violet's a different color. It's not in black. And when I hit enter, it changes. Now, that's just your one line of code. It gets annoying to, it's sort of like command line if you do code. So what I want to show you in NetLogo code is that we've created two functions here. This is a function, whatever happens between the word to and the word end in this setup function is what's going to execute when they hit setup. So currently, when I hit setup, if I look down here, currently, this is the code for create a turtle and make it size 3. So I'm just going to show you a little bit about the breadth. I wouldn't go this fast. I would literally, if I was teaching it to you guys, I would make sure everybody actually had success at this point. Because really, what I really want is all of you to like be able to change the color on the screen, to be able to add something and be able to see how that goes. So I'm going to show you how you can add to a function. I can say set shape. And I can go here to my objects. I'm going to try a fish. I'm going to come back in here. I'm going to check a shape to a fish. Okay. Now, fish has no meaning to this computer. So, it's just one of its six syntax that when I'm talking about an object, I have to put it in quotes. And you notice that it changes its color. And it's this color coding that I like for beginning users, right? It's all or nothing. It's either a color or it's probably wrong. So here I have this because I need to go up here and to recompile my code. I asked it to make a change. When I recompile it, I ask it to think about it. So when I hit setup, I have a fish. And there's something random about colors every time. Every time I'm hitting setup, I am creating a new object, right? Which is sort of a trip. And you can see that as this. I'm going to show you what a go function does, and I'm going to open it up for questions and see if you guys have. Okay, so in between the to and the end, the words to and the word end, is the function of what happens when I press go. So when I press go now, nothing happens. The go function is a little different. In a go function, it means it does something every tick. So for instance, if I say forward 1, FD1, and this is all in the code cheat sheet, FD1, and I recompile my code, I am going to, can't use go in observer context, I'm going to hit setup, because go is turtle only. Oh, okay. Ask, I have to, so I had an error there, right? It's like, hey, you can't just do that. And it's because I didn't ask nicely. I have to say ask turtles. Okay, and then everything I'm saying has to go in square brackets. Ask turtles to go forward 1. All right, so I come back here, I compile my code, and now this doesn't look so crazy. It doesn't look red. I hit setup, and when I hit go, there's just a ton of fish. Now, and that's because every time I'm hitting setup, I am adding to the screen. Computers and algorithms are very specific. I can only do one thing at a time, right? I can only do what it was specifically asked of, right? So if I wanted to stop, I hit go again, but then I can do that. And so very quickly, you can get a shape, you can get things to move. And for some students, they love this. I had one student in my county 1 class, and he was like, Mrs. B, are you telling me that I can make art with math? And I was like, yes, you can. It was my wonderful moment. He was like, get out of here. So some students do amazing with this. Some students are like, not my thing. And for them, I would put them on block coding or visual coding or other things. But to at least understand how a little bit of this works, I feel like it begins to demystify this. And that's what we need for kids to not make up their mind, right? It's very much like, nope, I don't like math. I don't like computers. I don't like code, but they've never tried it. They don't know. And in essence, the best coders are creative. They're problem solvers. They're people who are good at languages and who love solving puzzles. Okay, so with that, I am going to open it up to questions and talk to you guys and see, what did you think? Do you feel like, and I will say, I don't know if every student's going to code in it, but I do believe in the power of every single student coming and playing with it and exploring it. And that's what on this Ninja Panda site, when you come to this student, when you come here and say, I'm a student, oh, I hope that doesn't play. Here is all the lessons they need to explore. Here's a video telling them how and a worksheet. And if you go right here, it'll take you to the site, right? So I tried to make it as simple as possible, but right now, I want to see what you guys think. So let's open it up to questions. Yes, I will share this presentation with you, and I will just do that right now for you. So what other questions do we have? Can you see this? Can you see yourself using this exploration as your emergency sub plan? You think this is great? You know, for a coding environment, it's super user friendly, right? It's pretty, it's a kind editor, right? It can be really easy to use. And really quickly, kids like create really cool art with it, right? And yeah, and for a non-coder, right? That's what I want. I want it to be easy. I don't want, as a computer science teacher, I can tell you, it is hard to get everything approved and on the right computers and all this kind of stuff, right? And so I'm really glad that we just have this. It's a website. Literally, if you couldn't get, if you, even if you didn't have internet, you could, I used to try to do this locally just on a HTML file. Yeah. Yeah, I agree. So Dr. Joel Nelson saying using code.com, and you'd like to expand the opportunities. The other thing I think kids really like is that it's real, is that it's not for kids, right? It's not for kids. It's like real scientists doing stuff, right? Like spending years of their life putting these models together and sharing them. Yeah. Are there materials available? Yes, there are. Okay, so here is, let me come up here. There are materials. So for instance, when you're on when you're on the Ninja Panda site, here are, well, let me tell you a few things. As a teacher, I have, say I'm an educator. Here is a lesson overview, links to exploration sheets, my email if you ever need me, more, how would you code in it? When you are a student and you're in it, all your materials, like for instance, your coding materials would be here. So here's your color chart, your shape chart, your worksheets, and a cheat sheet on code, right? And then everything's embedded in here. So really with the Ninja Pandas link, you should be able to do everything. But I'm going to come in here. I want to share with you this presentation. And I feel like, copy. I'm going to put it in here just in case, and we'll try to get this up on the website too. So here's the presentation for you. And my email's on that website too. So the presentation has links to the website, links to your plans, everything should be there, but my email's there too. So if you have questions, or if you are scared to do this alone because you may not have all the answers, well, you don't have to have all the answers. That's the most important thing. As a teacher in code, you will never have the answers. You will always make mistakes, and modeling making mistakes and how you find them. I mean, you can literally go on Google and say, how, in that logo, how do I change a shape, right? I literally Google with my students all the time to show them exactly how I find information, right? Because they will never have all the information out there, but we can show them how we find it and how to persevere. So thank you very much. It was a pleasure showing this to you. Reach out to me if you have any questions, and I wish you MacGyver luck, right? May this sub plan come in handy, help you, and I thank you for sharing this mission to get computer science and data science into the hands of our students. So with that, have a wonderful conference, guys. Thank you.